So this is part 2 of the solutions for exercise 8.7. In the previous exercise we showed that this rule here was admissible in propositional logic. So we showed that line 4, PL3, was valid. And so in this part we're going to look at if PL2 4 is valid. So what they've taken is line 2 and line 4 as assumptions, and they've concluded with line 5. So what does this look like? In the previous one we had this rule, so here we would need to construct a type of rule that applies to this use of PL. So what do we have? We have existence of B implies existence of X, existence XB implies existence X, A implies B, and then we have negation of A implies existence X, A implies B as assumptions, and we get A implies existence X, B implies existence X, A implies B. So a rule like that would be, for example, N B implies Z. That's the first one. So B is just this B here, and Z is this here, same as last time. And then we have the second assumption. We have the assumption from line 4, which is the negation of A, which we are just going to call the negation of A, and then our Z again. So we have B implies Z, and we have the negation of A implies Z. Negation of A implies Z. So these are our two assumptions that we have, and what we conclude with is A implies B implies Z. So we have to conclude with A implies B implies Z. So we this is the rule whose admissibility that we need to verify. So same as last time, we first will construct a truth table to show that the rule is sound. And again, I'm not going to make you wait through the truth table. Wait, you have it here. Here we are. Just going to make it a bit smaller. So what we need to do this time is we need to see that every time B implies Z is true and negation of A implies Z is true, then the conclusion is also true, so that the rule is sound. Which means that we have to pay attention to this column and to this column here, and check that whenever these are true, the final column, A implies B implies Z, is also true. So first here we have true for B implies Z, but negation of A implies Z is false, so it doesn't matter that the final column is also false. Here we have B implies Z is true, so this one's true, and A implies Z is true, so now A implies B implies Z must also be true, that's correct. Here we have that's false, so this row doesn't matter. Here we have that both are true, so the final one must be true, that's right. Now we have B implies Z is true and negation of A implies Z is true, so A implies B implies Z is true. Then we have true, true, and true, and for this line it doesn't matter, but for the final line we have true, true, and true. So we've shown that with this truth table, whenever B implies Z is true and negation of A implies Z is true, that A implies B implies Z is also true. So the rule is in fact sound. So let us assume that we have B implies Z and negation of A implies Z. And so by soundness of N, we have that B implies Z and negation of A implies Z are valid in propositional logic. So by soundness of N. Soundness of N. So by soundness of N, we have these two here from these assumptions. So it's provable here, and here it's semantically valid. And since this rule is sound, we have that this gives us that A implies B implies Z is also valid in propositional logic. So by soundness of the rule, which we've just shown with the truth table. So now we have A implies B implies Z is valid in propositional logic, but we would like to conclude with this line here just to show that this rule here is admissible in N. But we know that the N system is not just sound, it is also complete. So by completeness, we come from this line here to this line here. So by completeness, excuse my handwriting, of completeness of N, we then have that it's provable that A implies B implies Z. So now we have shown that the rule is in fact admissible in the in propositional logic, and therefore line 5 is a valid transition according to propositional logic.